Hi there, Alberto Savoia here, and welcome back for lesson number 5 in the math of success for product managers. Now, I will tell you, the last lesson I did not go over too well with about 95% of you. Why? Because I had a formula which scared a lot of you away. So even though it was pretty simple, it is loud and clear that a lot of people do not like to work with things like probabilities. So first I was a little disappointed, or a lot disappointed. You know what kept me up? That 5% of people that really dug it, that liked the math. But for me, that's not good enough. The material I teach is so powerful that I want every product manager to have access to it, even if they're not interested or do not like math and do not like probability. So don't feel bad, you're like 95% of the population. So what I'm going to do for you in this lesson, I've taken 2 days to try to simplify things as much as possible. You will not see a formula, you will see a method for using the formula without having to pull out your calculator. Right? Remember this little guy? Out. We don't need it anymore. Sorry, little guy. So I come up with a system, so I'm actually very proud of it because I never had to simplify this, and this for me was a challenge, and I'm very excited. So without further ado, let's dive into it, and I hope that you get it and that you like it this time. All right, so of course, if you haven't seen the previous lessons, kind of go back because some of that material is necessary. But here's our scenario. Remember, I came up with the idea that for forever markers, that you just dip them in water and they keep writing forever. They cost 10 times more than regular markers. I need to invest $1 million to develop them. I want to know if there is a market for it, right? The number one question a product manager must know how to ask and answer is, what is the probability that this product will succeed in the market? So the first step, we create an XYZ hypothesis. This is how we define success. So the XYZ hypothesis for this product is at least 20% of marker buyers will buy forever markers for 10 times the price of regular markers, so $50 for a set of 4 instead of $5. And then I put, by the end of Q4 2021. So we're gonna dot there. So this is a big hypothesis about the whole market. Now, remember, market hypothesis especially, exists to be tested in the market. So what we did, we hypozoomed, right? So we zoomed from this big hypothesis to a small hypothesis that we can easily test here and now, as I explain in my book. By the way, I have to put in a little plug, it will make my publisher happy. If you buy my book, please buy me, only like less than $20 online. All of this will make so much more sense. I'm augmenting and complementing the book. But as explained in the book, there is a technique called hypozooming, where you take your big market hypothesis and you zoom to a hypothesis that you can test very, very quickly. So we zoom to this little hypothesis, testable, little XYZ. At least 20 out of 100 Office Depot marker buyers today at the Office Depot on El Camino in Mountain View, near to where I live, will buy forever markers for $50. So again, what we've done is we've taken this big hypothesis for all market buyers of all times, and we want to test it in a small scenario, right? Because if this is true, then this should hold true, all right? So we came up with this little test, and we came up with a prototype experiment that I explained in the previous video. Now, so we run this experiment, or a series of experiments, where we look at 100 people that come into an Office Depot and try to buy markers. We count how many of them buy our markers. How do we interpret the data? How does it change our probability of success based on the data results, based on the data from the experiments? That is what the formula, the base formula, which I think is so beautiful and many of you think is just complicated and confusing, did for us. So what I did, I wrote a little program to create a table of all the possible combinations, because remember, one of my simplification, we only have 5 possible outcomes in terms of likelihood of success. Very unlikely, likely, even odds, likely, and very likely. Right, so as we explained in previous videos. I always get confused. Very unlikely, almost nobody will buy. Unlikely, even odds, likely, and very likely. And to those we assigned probabilities. Oh, but wait, I'm not going to talk about probabilities. That's another thing that I learned from you. 30% is equal to 0.3, but somehow a lot of people have trouble mapping that. People are much more comfortable with percentages than probabilities because they use percentages in life all the time. So notice I've eliminated any of that. All you have here is percentages. Okay, so we run the experiment, you run the market experiments, and you're gonna get a result. You know, you're gonna see if you're gonna try to sell 20 out of 100, how many come back. So instead of using the formula, I created an experiment scoring card, right? So remember, your goal is to sell at least 20 out of 100. That's in the XYZ hypothesis. So depending on how many you actually sell per experiment, you assign it a score from -2 to +2 with an explanation of what each score means. So you wanted to sell 20, at least 20, and you sold a number between 0 and 9. Would you agree? That's a much worse than expected result, right? Even if you sold, especially if you sold 0. So that you scored a -2, and it's easy, you know, before you put the score to say, well, this result is much worse than expected. If you sell between 10 and 19, you call it worse than expected. You were hoping to sell at least 20. Even if you sold 19, you're falling short. That's a score of -1. If you sell 20 to 39, this is, I'll explain in another video how you set up this scale. 20 to 39, you're doing equal to or better than expected. So you score a +1. If you sell more than 40, you're doing much better than expected, right? You were hoping to sell 20, you sold 47. That's much better than expected. So you score it as a +2. So you're starting to see the power of using the XYZ hypothesis, because in the XYZ hypothesis, you put down a number, right? Say it with numbers. And once you have that numbers, you can base other estimation based on that number. So I'm saying here, if you're selling twice as many as you were hoping to sell, that is a very good result, much better than outcome. You see, as you go through my videos, and some of them you may have to watch once or twice, you will see that everything I teach you is like a puzzle that comes together. Every single element, the XYZ hypothesis, the definition of success, they all tie together in a very tight system. I'm an engineer, I am a programmer, I build hardware, I build software. If things don't fit, you turn it on and it doesn't work. So my goal is to give you a system where everything fits, and you're starting to see the benefits. So how do you use this result? Well, what I've done, as I said, I've created this table, all right? So over here, you have your probability of success, right? This is P of S, that's what you want to show. What is my probability of success for my new product? Is it 10%, 30%, 50%, 70%, or 90%, right? That's what you want to do. Now, notice I put something here, I call it my go, no go line. What I'm saying is, look, if I cannot have a confidence, at least 70% confidence that my product will succeed in the market, I am not going to spend the $1 million to develop it, okay? So here we set the goal. Now, remember from a previous video, where do you start? What is your initial probability of success before you've done any experiment, before you've collected any of your data? If you remember, I set it at very unlikely. That's 10%, right? So here's where we are. Your probability of success off the bat is at 10%. Very unlikely. So now, that's why we do experiments. And we don't like this number. I think my idea will succeed. I said, great, let us do some experiment. So what I've done here, I've created cards for 3 sets of experiments. I shuffled them. So let's pull out, and let's assume that we're doing 5 experiments, say over 5 days, say at 5 different Office Depot. We're gonna try to put these markers on display and see how many people actually sell them. So let's pull out the first set of cards, okay? So we have 5 experiments. This is the first set of scenarios. Right, so on the first day, I do the experiment, and let's see what card I pull out. I sell 17 out of 10, all right? So here's how we score it, remember? 17 out of 10, I was hoping to sell at least 20, I sold 17. The result is worse than expected. So what does it do? What does it mean? It means that we stay here, -1. You started here, you got worse than expected, right? So we're doing this line now, worse than expected, 10%. And you would agree enough, my goal is to sell at least 20. This result doesn't necessarily look very encouraging. So we do not move the line. Now, Alberto, Now, I know what you're saying, Alberto, but 17% is so close to 20. I said, yeah, but you know what? 20, we said it as the least, that's a minimum level. So even though 17 is close to 20, 20 is the lowest minimum, so I'm sorry, you haven't met the mark. So worse than expected. That's the first result. So you're a little disappointed, but 17 is better than 0. You go on the next day, you run the experiment again, because you never make decision based on one experiment. Even science works on multiple experiments have to be confirmed. So you do another experiment, and whoa, this time you sold 27 out of 20. So it falls in this range, equal to or better than expected. So what happens? You're still here at 10%, but you're at equal or somewhat better than expected, and there is a 30% here, right? So you started here, your result is equal or better than expected, 30%. You know what this means? That as you might expect, this is a good result. It increases your confidence that the product will be successful, not by a lot, but enough to go to the next level, right? And this is based on the formula, but you don't have to deal with the formula. So guess what? You had two experiments. One was not very conclusive. The other one gave you a better result. So you can move to the next level. So now you're here. Let's pull out another number. This time you sold 23 out of 100. You know what? It is still better than expected. So it's a +1. So you go to the +1 category. And where do you end up? So you're here, +1, somewhat better than expected, 50%. So you now raise your probability of success, your chance of success, to 50%. So in two experiments, you've gone from 10% probability of success. You had one inconclusive one that wasn't that particularly good, did not move the needle, and two positive one. But notice, most people, if you don't do market research the way I teach you, you get a good result and you lock into that first result and say, great, we wanted to sell 20, we sold 27, let's launch it. But you need to do multiple experiments for them to be statistically significant, okay? And I'm not gonna bother you with statistics, but just trust me, this is a good simplification. So you just move from 10% to 50%. That is a pretty damn good result already. Right, so we say, okay, we need some more experiment, because remember, I wanna reach this go-no-go line of 70%. So we pull the next card. Wow, that's another good one, 25%, all right? So 25% is better than expected. So it's in this column, and I'm in 50, so guess what? Now I'm moving up to 70%. So I've kind of reached my no-go line. I wanna be a little bit more sure. I do another experiment, and guess what? This time I get exactly 20 out of 100. It's equal or somewhat better than expected. So actually, I'm well over this line. So I'm at 90%. And by the way, this is as high as it goes, right? If you use my system, you can never go less than 10%, and you can never go more than 90%. Why? Because when you're dealing with markets and with people, you don't have more accuracy than that. So it's always like 30% plus or minus 10%, 50% plus or minus 10%. Okay, so that is the first scenario. Now, you start to see how to use the formula without actually using the formula. There are some simplification here, but the goal, right? The goal of mathematics, Nassim Taleb, who wrote several great books, including Fooled by Randomness, one of the comments he makes is that mathematics is a tool for meditation. Not for sitting down and doing Buddhist meditation, but for just thinking about the problem. So even though you're not using the formula directly, what you're doing is you are using it implicitly. You're realizing, I need to do some experiments, right? I need to get some insight, some wisdom. So you haven't used much math, but you've done what the math is leading you to do, which is to conduct multiple experiments. Okay, that's scenario one. Let's have fun. Let's go with scenario two. Start again at 10%. Let's pick another set of 5 experiments and let's see how this works, okay? So I'm gonna shuffle the card, and let's pick the first one. All right, your first result, you sell 5 out of 100, okay? So this is definitely a -2. So you started here, result is much worse than expected. You don't move, you're still there at unexpected. You go in the next day, maybe a little bit more hopeful. Oh boy, This time we pulled a 1 out of 100. Still, much worse than expected. You don't move the needle either up or down, right? This is as low as you go, much worse than expected. Go in the third day, let's see, oh please, I hope it works out better. Oh my God, even worse, you sold 0. So still, you don't move out of this category. You're getting tired, but you say, okay, let's give it 2 more experiments. You go the next day, hey, improve, you sold 3 out of 100. So what does that mean? Is that you're still much worse than expected. The needle doesn't move. Final day, I said, okay, 1 more shot before we give it up. You go there and for some reason, because you're desperate, right? So you said, look, I really want this product to succeed. So you go there, you not only put them on display, but every time somebody comes and approaches you, you try to sell it to them. Say, look, you know, why buy these markers? You know, this will last you a couple of hours. This will last you forever. And through that hard selling, you manage to sell 15 out of 100. So you're doing much better, right? It's still worse than expected, but you know, in this case, you've biased the experiment, right? Because you're not going to have a person there trying to do the hard sell. So there is one result, one category of results we haven't discussed yet, which is inconclusive. We'll discuss this more in future videos. Sometimes a good scientist and an honest market researcher throws out the result. Why? Because it was compromised. There were some external circumstances, or maybe you tried too hard, you corrupted the data. That's not believable data. If you really, you know, put a cute salesperson and really trying energetic and try to sell your product, that is not replicable. So you cannot probably do it. Okay. So in this scenario, we've done 5 experiments and the needle hasn't moved at all. How common is this scenario? Unfortunately, it is the most common scenario because when most people set their first XYZ hypothesis, they're just so optimistic. Look at this, 20% of the market for people who buy these markers. Now, you know, that's a lot. That is very optimistic. You know, the companies that have been in business, like, you know, Expo Low Erase, they've been there for decades. They got the market corner. So this is your first dose of reality. It may hurt a little, but think about the alternative. Think if I'd spent $1 million to develop them, and then I find out that I'm lucky if 3 people out of 100 buy them, and that's too small for a store to stock them. Okay? So depressing result, a little sad of a result, but much less painful than if you invested time to go and launch the product. Remember the law of market failure. Most new products will fail in the market, even if competently executed. That's a big painful failure. This is a little experiment you did over 5 days at little or no cost. So it hurts, maybe your ego, but not too much. It doesn't hurt the wallet and your chances for success because you can come back, right? You can iterate, you have new ideas. As long as you haven't blown your $1 million in 2 years to develop a product that people don't want, you live to test another day to work on another idea. So I want to finish on a high note. So let's pick a third set of experiments, right? So we get a good feeling for how this thing goes. Okay, third set of experiment. By the way, these are all different scenarios, right? For this one, let's assume that this product is bound to be a success. So you go the market, so you shuffle the cards here, and on the first day you sell 39 out of 100. Oh, you're hoping to sell at least 20. You sold 39. That's a lot. So it's equal or better than expected, right? It's not much better than expected because it's just like 1 short of much better than expected. If you set these hard rules, live by this hard rule. One of my hard rules is for a result to be much better than expected, it has to be at least twice my X in the XYZ hypothesis. So I need at least 40%. This falls just a little shy, but still it's a good result. So where are we? We started here, 10% chance of success. We did equal or somewhat better than expected, so we moved to 30%. So after the first experiment, we are there. Now we do another experiment. Next day of experiment. Now we sold 43 out of 100. Whoopie-doo. I mean, this is good data. So now for the first time, we have a result that is much better than expected. Again, if you sell twice what you expect to sell in your XYZ hypothesis, you have my permission to call it much better than expected. So you're in this row now, and you go to the much better than expected column. It means that you move from 30% to 70%. You've done quite a big jump here, right? So here you are. You're now at 70%. You've met your go, no-go line. Now, it's a big jump. So in theory, if you're just lazy, just do 2 experiments and you stop now. But let me ask this question. How many experiments should you do? Yeah, to confirm that your idea is the right that it will succeed in the market. Well, it's a function of how much time and money and effort you're planning to spend. If these markers require 1 year of development and $1 million, do more experiment rather than doing fewer experiments. You know, you really want to confirm this. So we do another experiment. This time we sold 23 out of 100. All right, so 23 out of 100 is equal to or better than expected. So we go to the chart. We're here now, and we sold 23 out of 100. This allows us to move to 90%. All right, why? Because we continue to get these positive results. So here we are at 90%. Now you go and say, well, boy, the partners say, this is too good to be true. I said, okay, let's do a couple of more experiments. I mean, because it's fun, you know, once you have a product that responds, to which the market responds well, it's exciting. So you do another experiment, now you get 19. Whoops, a little bit of a surprise here. So now you get a worse than expected. Okay, you're here, you get a worse than expected. So in this case, it tells you to drop down to 70%, right? So I'm in this column, I got a worse than expected. All right, you know, by the way, this happens. Sometimes, that's why you do multiple experiments, right? You won't need to confirm. But you say, okay, let's do one more experiment. I mean, this is where we wanted to be in the first place. You do another experiment, you get 45 out of 100. So you're here, you did much better than expected. Bang, you're here solidly. Probability of success given data from your experiments is at 90%. Again, could it be more? No, not in my book, because you know, always allow for at least a 10% chance that things would go wrong. I mean, imagine I had the perfect layout for my plan to launch an Italian restaurant, and COVID-19 hits, and all of a sudden I can fail. So I'm never more cocky than 90%. I reserve a 10% chance of failure. So in conclusion, what I've done, what you've seen here today is a massive simplification of a very, very powerful system and formula that I introduced in the previous video. So if you like math, go and use the formula that I showed you and explained in the previous videos. If you don't, you're not going to miss much, if anything, by doing this, because the goal of mathematics here, you know, if you're a math geek, you do math for the pleasure of it. I'm in that category. Most people, math is a tool, you know, applied mathematics. The purpose of math in product management is not that you play around with numbers, it's to help you do the right thing. So if this tool that I've shown you helps you to do the right thing, which is very simple, experiment to confirm your market hypothesis, to run several experiments and adjust in an objective way your belief based on your experiments, then the math has accomplished its goal, right? Remember, math as a tool for meditation, for getting you to do the right thing. So I hope you like this simplification. I will post on my LinkedIn and on my Twitter feeds. I will have a PDF, a beautiful version of this table. And as a last thing, I spent like 2 hours trying to do this big enough so it would show well on this whiteboard. So it's a lot of work for my part. Again, it would be a huge favor to me, a nice way of saying thank you, if you buy my book, The Write It, available on all fine online and brick and mortar stores. If you already read it, you can also give me some skin in the game and be nice to me by writing a review for it, because I like reviews. So enough plugging, and thank you so much. I hope this was really helpful for those of you who are not math fiends the way I am. Thank you so much, and I hope to see you soon again. Bye.